Thanks for joining me in today's lesson. In this first tutorial, we will use the Pythagorean theorem to find the missing sides of a right triangle. And we're into chapter 13, and we'll be looking at the Pythagorean theorem and trig ratios. Let's recall a few things we know about right triangles. Right triangles are triangles that have one 90-degree angle. They of course have three sides. Two of the sides are called legs, and the other one is called the hypotenuse. The Pythagorean theorem is a theorem that holds true only for right triangles, and it is c squared is equal to a squared plus b squared. I remember to start my Pythagorean theorem always with the hypotenuse first. The hypotenuse is represented here by c. The hypotenuse squared will always be equal to one of the legs, a squared, plus the other leg, b squared. And we can use this to solve for any right triangle to find a missing side. So let's look at our first example. We have a right triangle. I know this because of the little right angle here in the corner. And I know opposite the right angle will always be my longest side, which is called the hypotenuse. So if I'm setting up my Pythagorean theorem, I like to start with my hypotenuse, and I will go ahead and square that. And I will set that equal to the other two legs squared and added together. So I'll choose x squared plus 6 squared. You could do 6 squared plus x squared. And there's our equation. All I need to do is solve for x. I will be taking the square root eventually, but I cannot do that until my x squared is isolated. So let's get our numbers first. 7 squared, of course, is 49. X squared is still x squared, and 6 squared is 36. If I'm trying to get x squared by itself, I should probably take away the 36 from both sides. These are just my regular equation skills. I'm going to put the x squared first and say that that's equal to 49 minus 36, which is 13. And now that the x is all by itself, the x squared I should say, I'm going to take square roots. The square root of something squared will go away and just x will pop out, and the square root of 13 is the square root of 13. Notice in my directions it says please simplify our solutions, do not round. So this is exactly what I want. Square root of 13 does not simplify. Let's try another one. This is some review, of course, from from geometry. Here's our next right triangle. Here's my little right angle, so therefore opposite that is my hypotenuse. So I will start with my hypotenuse squared, and I'll set that equal to 40 squared plus 12 squared. This time my variable is actually already isolated. I do want to know what this number is, so I'm going to compute these numbers. 40 squared is a 16 with two zeros, so 1600, and 12 squared is 144. Add those together and we have 1744. I'm solving for x, so therefore I will take the square root of both sides, and I get x is equal to, now the square root of 1744, that's pretty high and even. I wonder if there's a perfect square that hides in there. I know a 4 is going to go in there because 44 is divisible by 4. So this is divisible by 4. But when I divide by 4, I get 436. And 436 is actually still divisible by 4. So I'm pretty sure that the highest perfect square that goes in here is 16. And it goes in 109 times. I just found that on the calculator. 16 is the biggest perfect square that goes in. Remember, we're simplifying. We're not estimating on the calculator, so we can use our equal sign. The square root of 16, of course, becomes 4, and the square root of 109, well, there's nothing more to do with that. So this is our exact simplified answer for x. And our final example in this tutorial. Here's another right triangle. I know so because there's my right angle, and opposite the right angle is my hypotenuse. If you'd like to draw an arrow just to always remind you to start with the hypotenuse, that's a great idea. The square root of 10 is my hypotenuse. I'm going to put that in parentheses so that I can square it, and that will be equal to x plus 2 squared, quantity squared, plus x squared, the other two legs squared. All right, let's see what we have here. So the square root of 10 squared becomes 10. X plus 2 is a binomial, and if I have to square it, that means that I have to write it side by side and FOIL. I can do that quickly in my head. I've got x squared plus 4x plus 4. And then I have this other x squared. Okay, let's get our like terms together. I've got 2x squareds here, plus the 4x, plus the 4, and that's all equal to 10. Well, if I'm going to try to solve for x, it looks like I have a quadratic equation. Quadratic equations, we should always solve, set them equal to 0 first, and then we'll probably try factoring. So since it's not equal to 0, let's subtract the 10. There are many methods to solving a quadratic equation, but all the methods require you to set it equal to 0 to begin with. I'm actually going to put the equal to 0 over here because it feels more comfortable. I'm going to factor this, and the first thing that I see is that I can divide everything in half. I'm going to divide this entire side by 2. I can basically factor out a GCF of 2, but it's not needed, so I can just divide everything by 2. So I'll have 1x squared instead of 2x squared. I'll have 2x instead of 4x, and I'll have negative 3 instead of negative 6. And of course, half of 0 is, well, it's still 0. And now I can factor. I'm going to put my factors here. Still, of course, set equal to 0. Please don't forget that. I know x times x will go on the front. There's actually only one option for 3, 1 times 3. And these are going to combine to give a positive 2x if I put the plus sign with the 3 and the negative sign with the 1. So this factor will yield a result x equals 1. And this factor will yield a result x equals negative 3. Now remember, we are talking about real life things, in this case a right triangle. Negative 3 cannot be the answer for x because then that means that one of my sides has a negative length. In fact, both of my legs would be negative, and that doesn't make any sense. So this is not going to be one of the answers. The only answer is x equals to 1. Thanks for watching this review of the Pythagorean Theorem, and we'll practice this more in class. I appreciate that. See ya.